All right, we are going to start thermochemistry today, which is all about heat and energy and temperature and how that relates to not only chemical reactions but also to physical changes like changes in state and things dissolving and stuff like that. So Unit 12 is all going to be about energy. And energy is the ability to do work or process heat. And you probably have seen these two before. Potential energy and kinetic energy are the two different types. Potential is due to what something is made of or where it is, what its position is. And of course, kinetic energy is the energy of motion, which we talked about with gases. So we're going to be focusing on the law of conservation of energy, which states that in any chemical reaction or physical process, energy can be converted from one form to another, but it's neither created nor destroyed. Okay, so if something is going to be losing energy, that means something else is going to be gaining that same amount of energy. The energy can't just disappear, and we're going to be kind of following the trail of energy through a chemical or physical process. And in chemistry, we focus mostly on chemical potential energy, which is the energy stored in a substance because of its composition. So it has to do with the types of bonds and how strong the bonds are and which bonds are broken and which bonds are made. So heat is what we're going to be looking at most in this particular unit. And heat is energy that's in the process of flowing from a warmer object to a cooler object. So anytime you touch something and if it feels warm, that means heat is going from the object to your hand. If you touch something and it feels cool, that means heat is flowing from your hand to the object. So there's always going to be a transfer of heat if two different objects are at different temperatures, and that heat will be transferred until they're at the same temperature. Now we're going to be using the symbol Q to represent heat, lowercase q, so that's important for our variable for heat. Now there are two different units you can use to measure heat. A calorie is one of them and a joule is the other one, and we're going to be using joules. Now a calorie, you usually hear about calories in terms of food calories. Well, food calories are capital C calories, and those are equal to 1,000 lowercase c calories. And a little calorie is the amount of energy required to raise the temperature of 1 gram of water 1 degree Celsius. That's the definition of a calorie. So when you talk about food calories, it's 1,000 of those little calories. Now when we use the term joule, J-O-U-L-E, this is the unit we're going to be using more than we will calories. And you can see over here in our chart we have conversion factors. These are the ones you're going to need to know right here to convert from calories to joules. 1 calorie is equal to 4.184 joules. All right, so let's take a look at an example of a unit conversion with calories and joules. All right, it says a breakfast of cereal, orange juice, and milk might contain 230 nutritional calories, and you'll notice that those are capital C calories. Express this energy in joules. Okay, so we're going to start with what we're given and do some conversions. So 230 capital calories, that's what we're given. We know that 1 nutritional calorie is equal to 1,000 little c calories, and then we want to convert to joules, so there are 4.184 joules per calorie, and joule is represented with a capital J. So our units cancel, we have joules, we take a look at our sig figs here, which is 2, we multiply across and we get 9.6 times 10 to the 5th joules. Now you'll notice that's a really big number. A lot of times we will use kilojoules instead of joules, so the numbers are a little bit smaller and easier to work with, and there are 1,000 joules in 1 kilojoule. So kilo is our prefix just like any of our other metric prefixes. So we will use that conversion factor as well.